Well, it's just 4 o'clock. So welcome all to the webinar on onion diseases. We will hear today from the latest from the current disease research projects. So there will be Michael Rettke from SARDI talking about reducing impact of Fusarium, which is a problem everywhere, but especially in South Australia. But we better be prepared in other states as well. In some areas, white rot is quite a problem. And so we will hear from Phillip Frost from Arvensis on one of the Hort Innovation and levy funded projects on optimizing chemical control and culture control. And that's been going for a year, I think, for a good year. Then Dylan from the Sumich Group, Dylan Bellchambers, will talk about some of the commercial aspect of dealing with onion white rot. How significant is it and what is done in practice? And then last but not least, some very exciting development in actually looking at new fungicides or a new fungicide that might help managing white rot. Because as we know, sometimes the culture methods still lagging a bit behind. So we will hear in the order I mentioned people. The webinar is being recorded, so hopefully that is all right with everybody. We've got the acknowledgement of the funding body, Hort Innovation, and obviously the onion levy. So thank you to Hort Innovation and all the growers who are funding and helping us to do the right thing. Everybody should have their microphone on silent unless they want to speak. I just have to let a few more people in, if I can. Where are they? That's a bit of a problem with sharing something. I have to let them in a minute. So I don't want to bother you at the end with having to fill out a questionnaire, but there are some questions you might just want to type into the chat. You know, how did you hear about the webinar? And also which diseases you are concerned about, apart from the diseases we are talking about, or also pests. Just type away in the chat. If you want not everybody to see it, you can just send it to me. And then also just questions that presenter should answer at the end of the webinar. So there's 3 things to really talk about or type into the chat. How did you hear about it? Issues in your region where you need more help, more research, and then questions to presenters, which might be actually some of it overlapping, you know, the last 2 questions. And then in the end, I will remind you again on the other questions. So I'm just admitting some people, sorry. So really, I stopped sharing now. And we start with the first presentation from Michael Rettke from SARDI on managing Fusarium basal rot.
Morning too. Being hit by that.
Could everybody please mute their microphone, including me, obviously?
I've got a mute. Yeah, I'll mute.
What good is it?
Is the presentation up yet, Doris, or not?
You're good to go, Mike. I can see it.
Oh, okay, that's all right. Just going to hear Doris. Okay, thank you for joining us today. I'd like to talk about the Fusarium basal rot project, which we've started and working our way through. I guess at the first thing is, I suppose we're sort of focused. I've put 3 pictures up there. I mean, Fusarium basal rot. I mean, Fusarium in general in onions can cause a lot of things, but we're primarily focused on the basal rot, which is the centre picture there, characterised by rotting of the basal plate, white hyphae around it. But it's also very important to acknowledge that these problems actually start way back in the field, even if they happen in storage. Most of the infection happens in the field, and it can happen very early. So if you've got severe infection in the field, you can see that you can actually get symptoms out in the field, and you can get, if the temperatures are warm enough and conditions favourable, even at the seedling stage, you'll get damping off from Fusarium as well. There are some other symptoms, like in white onions, you can get pinking as well. So we're sort of covering all of those, because mostly around the world it's been accepted that Fusarium oxysporum cepae is the main cause, but that's not necessarily always the case. So I will go through some of the samples that we've done before I go on to where we're fitting with the project. For those of you who aren't aware of how this project's structured, and I suppose the way we're going about it, is that we're going to obviously review all the literature, talk to researchers both here and overseas, and latest research reports. Now, Fusarium basal rot's actually a pretty big problem globally. So there's actually quite a few people grappling with it. So there's a fair bit of research been done even in the last few years. So quite a few papers been published. That's a good and a bad thing. It means we've got stuff to work with, but it probably also is reflective of the challenge that the disease is. Obviously, we also need to take lots of inputs from the local industry, both in terms of how they're going about it, what they're doing, what the level of incidence is, which areas of Australia that it's important in. But we also, any ideas and concepts they have or we have, they've actually got to fit into the system. So when we get to the stage which is in the centre there, we need to be working at things that can be adopted, right? So as I said, we actually had something very basic and fundamental to do in the first place, and that's actually to identify the causal agents. And you might wonder why we put so much effort into that. But at the end of the day, if it's different Fusaria, that's going to affect how effective your rotation strategies are. It's also going to change the epidemiology of the actual disease and where the infection risk would happen. So we need to understand, is it all being caused by the same thing, or are there multiple causes? And we'll show some of the symptoms we've tested, as I said, a bit later. We're about to start this year a fair bit of crop monitoring as well, and that's more about understanding and working out whether accepted, I suppose, understanding of what the drivers of disease are. So we'll, by monitoring, by temperature monitoring, water, like soil moisture monitoring, and also probably more importantly, looking at the infection as you go through the crop when it's occurring, because it will sit there as a latent type infection and then won't show up till later in the crop, or is more of the infection actually happening later in the crop? So it's important for us to get a handle on that, because that ultimately depends where you've got to put your strategies in. I suspect they're right from the start, which is why sometimes seed treatments, though they're not registered in Australia at the moment, are possibly, going to be part of the system, I suppose, and controlling inoculum very early on. Now, I guess we wrap all of that up, and we're not aiming to investigate all management techniques, right? While I've listed them all there, some of those, there's reasonable amounts of information and research on them and knowledge, and they basically become part of an integrated control strategy, which is what we're after. But we're looking at where the gaps are in that. So, chemistry is one of those gaps, but there's also a lack of knowledge about how effective rotation crops are and things like that. So I'll go through some of that and where I think some gaps are. And that way people can give me feedback on whether they think there are additional gaps or the way we go about those gaps. And ultimately, it's not going to be a prescriptive, integrated, disease plan. What it is because people's systems are often different. It's basically giving you a lot of choices that you can fit into your own system and that are, I guess, got some sort of backing behind them. Okay, so you can all see a bunch of symptoms there, right? So I just compiled a bunch of, I just kept going until I filled up the page with our symptoms and put a bit of a spread of them as well in there. So these are all ones that because we've actually got our Fusarium oxysporum cepae test working now. So we have a routine test that we can operate in the lab to test for this. So we've only actually got the data from these samples in the last 2 weeks. So, and what we'll then move to then is without going into much of the details, we'll go to next generation sequencing to look for other Fusarium species, very Fusarium specific testing model that we've developed in-house.
How are you? Good.
So,
Did you guys finish on tomatoes?
right. So,
you finished tomatoes?
yeah.
Are you
I
guys
think
gonna pick
someone
again,
might want to
or
put their thing on
where
mute,
you
I think,
guys gonna
possibly.
pick?
But so if we look through all of those symptoms that we've got there,
Friday?
um,
Saturday?
some of them look
Alright.
what you'd
I'll
call
go past there,
classical
that's it.
Fusarium basal rot.
Duncan?
So very typical symptoms.
Nothing
Others
yet.
are a little bit
Nothing
more.
wet.
There's some early symptoms.
Okay,
So which
that's
ones
good.
of those actually have got
Alright, thank you. I just
Fusarium
want to know,
oxysporum
that's all.
cepae as opposed to, I guess,
Okay.
other symptoms, right?
I
So,
know
or
some
sorry,
of that
other
also.
Fusarium species. There's also, I suspect, one that would be
Sure.
slated as
Yeah.
bacterial up there.
Take care.
There's a white rot sample in there just to see if there's any Fusarium cepae in that one as well, because often they operate not independently, and you can see a bit of penicillin on one as well. So there's quite a few other things in there, but it's about getting to the root of the cause. What's your primary cause of these things? And often basal rot will be that. So what I've done now is I've taken away all the samples that we didn't get a detection of Fusarium oxysporum cepae on. So as you can see, based on this, especially for the very typical symptoms, it is the main cause of Fusarium basal rot in Australia, right? But we have lost a few that are a little bit typical, and then we've lost a lot of other type symptoms as well. And we know that there's Fusarium in some of those because we looked at them under a microscope. So we know there is Fusaria there. So our next generation sequencing will actually tell us what they are. Other things that we found are Fusarium equiseti, Fusarium solani, and probably the most likely one that will come up and was on, there's only one garlic sample that I threw in this particular lot as well, because we're not focused on garlic, was it had Fusarium proliferatum, we know that. So, and that's possibly some of the other onion ones that have got slightly different symptoms. So we'll get our results from our next generation sequencing on that, which will help us with the way forward. And then as part of this process, we're also obviously getting a lot of isolates that we can use in our testing for efficacy down the track. So that's part of the process. So when I go, and I'm going to talk about management of soil-borne disease, I suppose this is, it's a list of things that are probably known to be, you know, in the mix for an integrated control system, but it's also a bit of a discussion of which ones we need to know more about to actually, you know, effectively use them. I think we've done enough on the correct diagnosis to base the decisions on. That's what that part of the process is. It's not only us doing it for the project, but as a grower, you need to know that you're treating the right problem. Okay, so if we look at management of soil-borne diseases in general, focusing on Fusarium basal rot, the first thing you've got to do, I guess, is you're looking at how you reduce the risk between crops. That's always your first stage, I suppose, with managing soil-borne diseases. Now, with Fusarium basal rot, yes, rotations, long rotations, you know, they have a level of effectiveness. They're not quite as effective as you might want them to be because it produces long-term spores which survive in the soil for many years without a host, and it can also act saprophytically to survive without a host. So that actually reduces the effectiveness of they can survive 4 years, the spores, so plus. So, I mean, a good management system would be about 4 years, but if you've got high infection levels, you're probably looking at 6. So, but then what are your rotation crops doing in there? And that's actually a bit of a gap. We don't know a lot about that. Whilst Fusarium oxysporum cepae is known as an onion-specific pathogen, it will actually host on other plants asymptomatically, which what we call reservoir hosts. So we don't really know enough about those, but we do know they exist because from overseas data, things like corn, black beans, some of the Sudan grasses can actually host it. So we probably need to put a little bit more effort into that. Weed control, the oxalis species, so Soursop, Scribbing oxalis, they will host it as well, so you really don't want them in the system. I guess the other thing that rotation crops, cover crops are going to do is build organic matter. Fusarium, if you've got competitive other organisms in the soil against it, we know that will have some level of suppression in it. And where they've had multiple onion crops, that has actually been shown it can be developed. But if you've got severe problems, that's probably not the way you're going to go first. But you know that by building that, you are actually building a greater defence system. Now we go into the managing the risk things. I'm not going to talk about variety. That's something, obviously, there is varietal resistance tolerance out there. And that's something you talk to your seed companies and that about. It's probably an important from us for selecting our trials and which ones we use. The timing of planting one is really all about soil temperatures. So, you know, it's a warm climate pathogen. So under 15 degrees C, it's going to be fairly minimal activity, and then it's going to increase up to 26, 28. So if you're planting into warmer temperatures, then you're risking early infections and you're risking damping off and that sort of thing. So that's something for a high risk paddock you might be considering of where you put that time slot in. Pre-plant treatments, several fumigants are known to reduce the level of inoculum in the soil and can be quite effective. So it's actually an option where you've got severely infected fields. Chemistry, we're going to look at that. There is some older chemistry out there that has known effectiveness. There's a few that have been trialled, and there are some newer chemistries available. So that'll be part of our thing. We'll be to scan them. Obviously,
Yes.
how far we go with that really depends on what the prospects of getting them registered is as well. So that's something we need to assess once we know that they've got some potential. The biologicals and biostimulants is quite an interesting area. There's actually quite a lot of work been done on that overseas. So your trichodermas, your bacillus, to a lesser degree, your pseudomonas, some of the strains of those have actually been stacked up against as effective as some of the chemical treatments in overseas trials. And a lot of those things are available in Australia, so they're definitely in the mix for when we're looking at an integrated system. I won't talk too much about the cultural side of things. I think it's kind of accepted that you're really trying to protect the basal plate. Like, so if you get damage to the basal plate, you're going to be increasing your chances of getting infection. So some of that's about, I suppose, even growth and not getting any cracking. If weather conditions go against you, that's obviously not that easy to achieve. And you know, it's easier said than to do to get nice even growth. But nitrogen's the other big part of it. I mean, nitrogen's part of getting yields, but it's also a balance of bulb quality. And ammonium forms of nitrogen generally favour Fusarium. So that's the other part of the equation there. And managing other pathogens. And I think one that we probably need to get to the bottom of a little bit there is we know that if you have onion magnets and anything that damages the roots like that, that's going to increase your chances of infection. But we don't, whilst there's a lot of associations with pink root and the damage that does to the roots and the potential interaction with Fusarium, I think we don't really know all about that, and the jury's out a little bit on that. So I think because we have tests for both of those and we can look at infection as it goes through the process, we may actually garner some new knowledge in that area, I think, especially as part of our monitoring activities on grower properties. I'm not going to talk too much about the harvest and storage management thing. Obviously, being a warm temperature pathogen, if you put your onions into cold storage, so 4 degrees C, there's going to be minimal activity there. You know, 8 to 15, there's going to be less. So when you compare that to ambient storage, you're going to have a lot more problems in ambient storage. And so there's that, but there's also potential, I suppose, with our tests that you could actually start looking at having an extra level of selection in which paddocks might be going to go to storage. I know there's a lot of varietal decisions and other things that go into that decision, but maybe identifying paddocks that are of greater risk quite early on by infection levels that you can't necessarily easily determine otherwise. I guess, so that goes through, I suppose, the things that are known to probably fit into an integrated control system. If we were to look at where we're at now, we're going, I suppose, into a controlled environment trials, laboratory trials, and some field work to really set ourselves up for the third year of the project, where we evaluate the, I guess, best bet options or things that we need to know more about in some field trials in the third year of the project. So I think it's still an opportunity for those that want to talk to us about and get involved, because we still got, you know, we're still in the earlier stages of the project, so we're still thinking about ideas and concepts and all that. and to have some input, obviously, then you also get to see things firsthand. So we're always happy to, to talk to people about what we're doing, what we're trying to do, and what they think, in terms of all of that. It's an important part of the discussions. So I'll pretty much leave it at that. My contact details are there, but they're also pretty widely available on the web. So, okay. Thank you.
Yeah, thanks a lot, Michael. So people have questions. You can go to the chat function by going to the bottom of your screen, and there's one button says chat, so you can start posting some questions, and we will get back to them later. Also, one question from me, Michael. You invited people to participate. Is that nationally or just for South Australia?
I've muted myself yet, have I? No. It is. Look, this project is primarily based in South Australia because that's where Fusarium. I should have. It's driving me nuts. The sun's coming out in South Australia. Would you believe? Coming in the window. Yeah, it is mainly a South Australian-based project, right? Because that's identified where the biggest problems are. We have taken samples out of other states, principally Queensland and Western Australia, but also a few out of Tasmania, though we probably wouldn't suspect it to be a big problem down there. But yes, most of our trial work and all of that's going to be here. But we're committed, I suppose, to keeping a dialogue up with the other states because we know that some growers in those areas do have significant problems with Fusarium basal rot. So, it's important to know whether it's the same pathogens out there, but also it's important just, I suppose, to have the ongoing dialogue whilst we might not have actual field trials in those areas.
Right. Thanks, Michael. It was really good to hear about the next step. There's actually, when we keep with the questions, I can keep the questions to the end. Otherwise, it's not fair to the other presenters. So we move to the next disease, which has been unfortunately hanging around for years and is still a problem, with Phillip Frost from Arvensis Research to talk about the work they've been doing on white rot for the first season.
You see that okay, Doris? Is that?
Yeah, beautiful.
Yeah, all right, thanks. And good afternoon, everyone. Thanks for coming along. As Doris said, I'm just going to give you a quick update on a new project which we've just started, looking at optimising chemical and cultural control of onion white rot. It's a Hort Innovation project. So I'll give you a quick overview of onion white rot disease, but Dylan's going to present in a bit more detail after me about the disease and the impacts commercially, but I'll just touch on a few things in relation to this project, and then Dylan will follow up with a bit more detail. I'll talk a bit about what we're aiming to achieve in the projects, and also there's some sort of very early results from the first 8 months of the trial, 8 months of the project, which I'll present, and then, as Doris said, there'll be an opportunity for questions towards the end of the presentations. But certainly, along with Fusarium, onion white rot is certainly one of the most economically significant fungal diseases in Australia. It's certainly a big problem down here in Tasmania where we're based, but also in other states to a certain extent as well. But as far as I know, it's not in WA at this stage. Being a soil-borne disease makes it extra hard to manage and deal with, and certainly it can survive in the soil for many decades, which can create problems as well. Cultural strategies like planting later in warmer soil temperatures or avoiding paddocks with high disease pressure can be pretty effective, but it's sort of coming to the point now where it's sort of backing growers into a bit of a corner where it reduces their opportunity for early sowings and spreading the production over the season, particularly that early harvest window, and also creating issues with sort of rotations on the paddock. So that sort of can, those, as I say, those cultural controls can create other problems. And certainly there's very limited management options available for onion white rot, particularly if you take some of those cultural control options out. The options are limited. So the aim of this project really is to as the title suggests, I suppose, develop a more integrated strategy and develop some more tools and options for managing and understanding this disease better. So the first part of the project actually involves Mike Rettke and SARDI. They're developing a DNA test as part of their other suite of soil DNA testing in their lab over there. So give the ability for growers to test the soil prior to sowing. I'll go into a bit more detail of that in a sec. We're also looking at evaluation of germination stimulants to reduce the disease pressure before you plant your onions. We want to understand the current 2 fungicides better and get the best out of those, and also develop some new modes of action and new management strategies for white rot. So the first part, as I said, is the DNA test. So the test methodology and process has been developed already by Mike in the first stages of this project. So that's all gone smoothly and was done fairly quickly. So the next step in that is really just the field validation of that test and developing sort of disease thresholds and looking at what the DNA test tells us, how that correlates through to disease levels in the crop and what happens to the disease through the season. So that's sort of where we are at the moment, and this coming onion season we'll work on some of those things to do that. So with the aim to offer this test in the future as part of the commercial tests offered by SARDI, and it'll probably be able to include not only onion white rot but potentially some other pathogens and nematodes and things like that in onions to be tailored to that. But that's sort of a little bit down the track, but that's the aim of where we get to as quick as we can. But certainly I think it will be a useful tool. Certainly in other crops and other diseases, the DNA tests have proven very beneficial just to identify your risk prior to planting and try and help with paddock selection and rotations and things like that from a commercial point of view. But also I think as a research tool it will be very valuable for this project to help us quantify disease levels in trials and also potentially the effect of some of the germination stimulants over time to reduce the disease pressure. So I think it'll have 2 uses and be very, very useful to help us understand what's happening. The second component here is germination stimulants. So as I said, the white rot pathogen survives as sclerotia or little dormant bodies in the soil and can remain there for decades until you plant an onion crop, and the onion crop or allium crop, it doesn't have to be onions, any allium crop, releases compounds from the roots which break down and stimulate the germination of these onion white rot sclerotes. So there's been a lot of work done over the years, and there's different compounds and different ways you can try and stimulate these sclerotes to germinate in the soil before you plant the onions, and because there's no crop of onions there, the pathogen dies fairly quickly. So it's can be an effective way of reducing disease pressure and minimising the build-up of disease in the soil. So there's a lot of work done a fair few years ago now with a synthetic product called DADS. Some people involved in the onion industry would be well aware of that. It provided effective disease reduction and sclerote reduction, but unfortunately for commercial reasons, it was never viable and never came to market. So once that fell over, we were sort of looking at potential other areas. Certainly, garlic extracts and other things that are commercially available can have an effect. Or we're also going to look at potentially just onion juice from waste onions, whether we can utilise that resource to stimulate germination of the sclerotes and reduce the disease pressure. So that's a bit more of a medium-term sort of outcome of the project, but it's something, an area which we are focused on, and I think potentially could have a big impact in helping manage this disease, particularly in bad paddocks, to reduce disease pressure. The next area we're looking at is fungicides and biological products just to manage the disease in crop. Currently, they're totally reliant on terbuconazole and triadimenol, which are 2 Group 3 fungicides. So in terms of fungicide tools or management strategies with fungicide, it is very limited and totally reliant on that one mode of action or resistance group, which is not an ideal scenario. So a big focus here is to look at alternative modes of action, some of the newer fungicides from different mode of action group, and incorporating those into a more sort of integrated strategy within the crop. So that's an area we're looking at, and potentially also some biological products to help, with root growth and suppression of the disease in the soil as well. So also as part of the fungicide work, as I said, terbuconazole and triadimenol, both used at the moment, are both very effective fungicides. So we also want to understand about how to get the best out of those in terms of timing and in relation to the disease, and irrigation and how all those management strategies affect those. So part of that will be, improving our understanding of the current fungicides plus the new ones. So I'll just present to you some very early data here from some of the trials we got in this year looking at fungicides and biologicals. So all the trials we do are replicated small plot trials in commercial onion crops. So these crops had the terbuconazole planting, and then we came in with a range of different post-emergent fungicides to evaluate them. So in those crops, we dig up all the bulbs, we assess the bulbs individually for not only size and yield, but also root health. So you can see in this photo here, these are all the healthy roots, so nice white healthy root systems. They've been snapped off a bit with the harvesting process, but you can see there that the health and vigour of those roots is really good. Then you can see here the typical onion white rot symptoms. So on the right, you've got the symptoms where you can see the white mycelium and black sclerotes actually up in the bulb. So that's where the disease has gone up through the roots and infected the bulb, basically makes it unmarketable or unusable. And then on the left, we've got the bulbs which are less severely affected, but you can see there the brown sort of dried up roots and certainly a lot smaller root system than the healthy ones I just showed you. So that's a more subtle effect of white rot that hasn't infected the bulb. So technically it's still a marketable bulb, but that severely affected the root development and bulb size, which affects bulb size and yield and all those sorts of things. So it can still have a dramatic effect on the yield and size, even though it hasn't infected the bulb. And I suppose also the fact that it's affected the roots potentially could spread into the bulb in storage as well. So we sort of categorise all the infections based on those two categories. Another thing, particularly here in Tasmania, where we did the initial trials, we see pink root is also another common disease, and certainly in all the trials we did this year looking at fungicides for white rot, we always found in the site as well the pink root. So you can see here in this photo, they're not dried up and brown like the white rot roots. So they're certainly a little bit more healthy, but they've got that pink coloration and a little bit of dieback as well from pink roots. So we still don't know exactly what the interaction, or if there is any interaction between the two diseases, but given they coexist and can both potentially affect yield, I think it's, even though the project's not on pink root, I think we'll also take a special note of that disease as we would with any other diseases as part of the project, just to check for any interactions or effects from that disease as well. Here's some early data from the trials. So because a lot of the products here we're testing are actually unregistered in onions, I've just labelled them as experimental numbers just to prevent any confusion or whatever. So what we've got here is, this is yield tonnes per hectare of healthy onions. So these are all the onions in the trial plot that have got no symptoms of either pink root or white rot. So there's a combination of the two here. You can see here on the left-hand side is an untreated control, which yielded just over 60 tonnes of healthy onions. The next one across is Alatron, which is a commercially registered or commercially used triadimidol, which is the commercial standard. Certainly got an increase there in healthy onions, which was good. And then you can see all the other experimental products on the right-hand side. So all these products are from, as I said, new modes of action and different groups. So I suppose the message here is that we've been able to identify some other fungicides from different mode of actions, which are certainly as good, if not slightly better than Alatron. So that's a positive. We'll certainly look to continue the evaluation of some of these products and look at how they might fit into the fungicide program for onions down the track. And certainly an aim of the project is to develop some of those products to the point where they can be used commercially. But just on that, in terms of new fungicides, there's actually going to be 2 new fungicides registered in the near future, potentially for onion white rot. Lunar Experience there is the first one, and Damien Odgers is going to talk about that a bit more in a minute and update us on that, so I won't talk any more about that. But the second one is Intuity, which is a group 11 fungicide, so different to triadimidol, Lunar Experience. So it's another mode of action, which has been approved by the APVMA and is just going through the final process of registration. So all going well, in another month or so, that product should be registered in onions as well. So both those will be very significant, and in that it'll give us another mode of action apart from group 3s to manage white rot in onions from a fungicide point of view. So and we'll certainly look at both those products in the project and how they might fit into the program and be best used. Just the final bit of data I was going to present is in terms of, as I said, we wanted to understand the current fungicides better and how best to use those. So part of the work is understanding that. So we did a fairly simple trial this season just gone, looking at Alatron, and obviously with post-plant or post-emergent fungicides, given that the disease is active in the soil, we really want to get the fungicides down into the soil where the disease is, and often that's through irrigation or rainfall. So that can be hard sometimes to manage in commercial crops, trying to time that around irrigation or rainfall. But so what we did in this trial here was we looked at Alatron applied 3 days, 0 to 1, or 0 days before irrigation or rainfall, just to look at, if you are tight for time and end up putting your Alatron on a few days before rain, what effect that has on efficacy. So this again is same as the data before. It's healthy bulbs, tonnes per hectare, so no rot with either pink root or white rot. We can see on the untreated controls, so this had no Alatron at all, we yielded 50 tonnes per hectare. Where we went with Alatron 3 days before rain irrigation, it certainly had an effect and improved the yield up to 70 tonnes per hectare. But where you went 0 or 0 to 1 days before irrigation or rainfall, we got another increase in control. So still works very well 3 days before, but certainly to work the best, it seems it needs to be as close as you can to irrigation or rainfall. So so that was sort of a nice, clear result there. And a lot of growers, are aware of that and trying to do that the best they can, but it's just good to have some data sort of clarifying that and the effect of that. We're also waiting just on the laboratory. We've analysed the leaves and bulbs and soil and everything in this trial to try and work out where the Alatron's going, particularly when it goes 3 days ahead of rain, just to understand that how much is getting into the soil. So I haven't got that data yet, but we'll have it shortly. So that's sort of where we're at this stage. As I say, it's very early days. It's a 5-year project. We're only sort of 8 months into it. We've made some good progress so far, but certainly the plans for the coming season, as I said, field validation of the DNA test to get that to a point where we can offer it, or SARDI can offer it as a commercial service and use as a management tool for growers. We're looking to evaluate some of the onion white rot germination stimulants. That initially will be done more in pot trials, controlled situations, just trying to fine tune some of that before we go to the field with it. And also fairly shortly, we'll be starting the second season of trials with the new fungicides and biologicals, looking at how we can best use particularly the post-plant fungicides, post-emergent fungicides in there. So yeah, that's sort of where we're headed now. So that's all I had, Doris. So I can hand back to you if that's okay. You just have to unmute, Doris.
I think you're still on mute
Yeah,
there,
my name's
Doris.
just unmute yourself there, Doris.
Well, that might, it's a good conversation with myself. Sorry about that. There's a question there, and I thought we might just answer that because it relates directly to the data, Phil. One was about the statistical analysis, any significance in the data, and the other one was the application timing of the trials. And I think that related to the last slide.
Yeah, yep, no, both good questions. So the application timing was, there was 3 applications of all the fungicides in those 3 trials. So that sort of tries to replicate commercially how Alotron's used, or triadimidal. So the first one was at about sort of the 1 to 2 leaf stage, and then sort of every 3 to 4 weeks for 3 applications. So trying to be as close to commercial practice as we could. And yeah, sorry I didn't add the stats onto the graphs, but yeah, a lot of those differences were significant. And the trials are all replicated. I think it was 4 to 5 replicates. So the stats are all available on those. We're just sort of writing up those final reports and analysing all that data at the moment. So they'll be all statistically analysed, yeah.
Yeah, and will they be made available through the communications program or milestone reports? You know, how can people access the information?
Yeah, no, it will be. Obviously, do milestone reports, but they're probably a bit harder to access for growers and industry. So we'll do, yeah, more sort of friendly communications in terms of the data. It's a bit difficult, particularly with unregistered fungicides, and that's why I've had to label them as experimental. We can't sort of publish information on things that aren't registered, but certainly I can, you know, label them as experimental or whatever and put them in there. So that data will be available. Or things like Alotron that are registered, I'll always put the correct name in for that, so it's easy to recognise.
But I mean, some promising early results, which is good to see. And
yeah,
maybe, as we just, sorry, Phil, you go.
Yeah, there's some pretty dramatic yield increases there. So with the fungicide treatments, and as I say, new modes of action, new chemistry, so it's good.
Yep, and you're looking forward to the DNI testing as well, because now your risk is always the first step. And just as we talk to the research project leaders, just quickly, Mike, there was a question there from Damien about whether you're trying cover crops and FBR, which I don't know what that is.
Oh, I think the FBR is just Fusarium basal rot. I assume that's what he's talking about there. Yeah, the cover crops, I think it is important, to know whether some of them are actually reservoirs and actually increasing, right? I mean, they can obviously, adding organic matter and other, you know, increasing other biology is going to have a potentially suppressive effect. But yeah, we do. I mean, there is some opportunity in there to look at that. And I know some growers are definitely starting to mix things up a little bit in that space. I guess our advantage now is, I suppose, we can actually test the roots of those cover crops and get a pretty quick actual read on whether it's hosting it and what level they're hosting from a FBR point of view, right? So
what's the turnaround time for the test?
We're not actually reporting it at this stage, Doris, because we've only had it for a couple of weeks. So give us
Why not?
we'd like to know a little bit more about it before we go too general with it. But we are running it on some size-based commercial samples out there. So we normally, our Hort Veg testing, which is the panel that it will sit on when we add it as a reportable test. So it'll be on there with pink root and root lesion nematodes. And I guess the white rot test will sit there as well. So we turn it around usually every 3 to 4 weeks. So we do a Hort Veg run. So, yep.
Yeah, thanks for that. Okay, keep the questions coming, people, but we now go to Dylan from the Sumich Group to hear a bit more about the commercial side and commercial aspects of living with white rot at the moment.
No, there you go. Yeah, basically into research and where I can in what future can come up this month, which is also very exciting because, as you touched on there, they are relatively limited and typically large concerns there is that.
Excuse me, Dylan, you're very hard to understand. Can you try to get closer to your microphone maybe? Or put some earphones in?
I've got earphones in. I'll just try.
I think that's better. A lovely smile
Okay.
on your picture. So if you go with that'd be all right.
No, thank you. So yeah, I guess there's a range of factors there for onion white rot. Both in the paddock growing the crop and also packing and storing the crop. Considerations to be made there. So I'll touch on, in the field to start with. I guess at a core, look, you see the photo there. It is can be quite a destructive. It can be very destructive white rot, and that's some pretty severe white rot there. But that's not uncommon to be seen either in patches or throughout a field at times where a range of different factors play to the disadvantage of you and can write off crops at times. So I guess at a base level, we also white rot is very prevalent, particularly here in Tasmania across the coast, as onions have been grown forever and ever, and particularly as Phillip touched on there, that it is soil-borne disease that exists in the soil for quite a considerable amount of time. So once you've got it, it's there for life, or certainly very hard to suppress or eliminate. So I guess that's the assumption of commercial growing, that there is white rot there, and we're certainly very much in a preventative strategy around that. That the assumption is that it's there either through it's been carried in through a machine or a previous onion crop, or just history through any other aims of supply security that hasn't been A1 as such. So at a base level, I guess white rot can. There's also just reduction in yield and growth of onions, cause onions not to get to size, meet commercial size, and then also increased waste through that way, or it can be further reduced and go destructive to causing secondary infections in the bulb, or either in the paddock or certainly in storage. So we do look to even if we used to get an infection, for example, in the field, quite often we'll see it just at a root level. You can see through tops indication that there's white rot, and also see unhealthy looking roots, as some of those photos that Phillip showed earlier there. So that assumption, just through managing it, once you've got white rot there, or that it is certainly active, some of the constraints we look to do include reducing water to that crop, or balancing, certainly avoiding free water to try and eliminate or prevent the amount of white rot that may enter the basal plate, which is far more destructive than just the bit of yield loss potentially than we may have through the reduction of water and not feeding that crop as much. So that there's a few challenges and management strategies there in the paddock that we do have, but again, they're still all not for the ultimate benefit of yield and quality of bulbs and onions. So quite a challenge. I'll touch on now just of if we've identified, for example, that we do have white rot at low levels, and certainly we look at that product very closely and certainly identify which markets we may or may not send that product to. Certainly, of our premium markets that you look to obtain really high quality product to, you certainly look at the risk factor of sending a crop that you either has low levels of white rot in or certainly not high levels. Certainly the potential for an infection through transport, secondary infection in transport is quite high. So you sort of, once you have white rot in a crop, it can see the risk factor in different markets and where you might choose to send that changes pretty quickly. You can be fortunate sometimes in the drying process or the curing of onion that you may have active white rot, and you're fortunate to get to a stage where you've cured it before you bring it into storage to strong levels. And if you store the product right, you can stop it from being active again, which does assist in some recovery of product. But at some point, it's likely that a reinfection or activity just through changing storage conditions, moisture is likely to return and activity return. So you've got a less robust product there as well, and it's your market access and opportunity there is reduced quite significantly, and the amount of time you can potentially store those products for as a result is reduced. And particularly when you look at Australian markets where there is a considerable amount of export focus, where we have to store products for considerable time to gain access to markets either overseas or required here to supply supermarkets 12 months of the year. We've got to maintain products and have product going out the door 12 months of the year. And with white rot in the mix there, it's very difficult to have products store for that long. We certainly know it's possible, very possible, to sort of have up to 9 months or longer. And in particular, with the product in packhouse, there's a very big cost of processing that crop, just in terms of grading. Like, it will slow down the production line very considerably. Identifying, because we really don't want any white rot to be entering that because of the very high risk that it'll infect and rot, and of course sort of a high quality product that we seek to be sending out. So sort of, I won't touch on this too much in the interest of being able to hear from Damien and get some questions at the end. It's touched on. We're quite concerned that we only got group 3 sort of control option white rot coming in yield. Sort of could be up to or more than sort of approximately $1,000 a hectare for growing the crop, regardless of what it yields. So it is quite expensive. And then there's certainly, as touched on there, the packing cost of that as well, which is I couldn't do a monetary figure, but is very significant through the grading line and things like that. So other considerations there that I guess we looked at free draining soils, and certainly how we prepare the ground, very much so to prevent free moisture being available in that rooting zone. I've certainly seen varieties that are potentially, with a more robust root system, to have some sort of levels of greater resistance as such to white rot, just through their vigorous root systems. So there are a few options there, but again, there's no silver bullet as such. And I'm certainly hoping that some of the research that Phil's doing there, we might identify a few more silver bullets, or certainly there's going to be more options in the arsenal in combating and suppressing white rot in the soil. So it's pretty good on that there. But in the interest of time, I'll finish up there, them in the chat, and look forward to hearing about from Damien about new product Luna there. So
thanks a lot, Damien, and sorry to the audience. We had slight crackling in the line, but I think we all could understand what Dylan was talking about. And certainly one aspect we often forget is the cost, increased cost of packing and grading a crop that's of not good quality. So that's quite substantial. So you lose out twice, once in the field and once in packing, and you might lose out in the market when onions arrive and they start to rot. So to prevent all this, we have got the research, and we have got Damien talking about a new product that should help a little bit, or really a lot. Let us know, Damien. Thank you.
Thanks, Doris. We'll certainly see you in time. Dylan, if you wouldn't mind stop sharing, that'd be great. I can share my screen. Thanks, mate. Can you see that there, Doris? I'll take that as a yes. No response. So
All clear here, don't I?
all clear. Very good. Damien Odgers is my name. To everyone who doesn't know me, I'm the business development manager in Bayer for horticulture. So thanks to Doris for that invitation to present today, and to all the other presenters. I want to give acknowledgement to Dylan here for this photo that I've got up on the slide, taken and provided. So thanks, Dylan. It's a great image of white rot and what it looks like. And yeah, so today I'm just going to share a few slides and a bit of information on the new product, Lunar Experience, which Phil and also Dylan mentioned previously. So the Lunar brand is part of a brand family of Lunar. We have two co-formulations in Australia. So to straight away make the distinction, Lunar Experience and Lunar Sensation. So today we're going to talk about Lunar Experience, which is a co-formulation product. And I'll just move my slides along. So just tell me when you can see the next slide. Yep. So Lunar Experience is a co-formulation of fluoropyram, a group 7 compound, and tebuconazole. So I think we're all very familiar with tebuconazole, as the other presenters discussed. But fluoropyram is certainly a new addition to the crop for this target disease. It belongs to the group 7, so it is going to be something a little bit different. So we think this is a really good combination of two highly efficacious products or compounds to target the management of onion white rot. So that's just a bit of an overview of what the product is, how the brand looks, and a bit about the chemistries in the bottle itself. This next slide just is a representative slide only. As it says at the right-hand side, it's not specific to any pathogen, but why I wanted to include this was just to illustrate that the two actives are very complementary to each other in that they do work at different stages of disease development. In the case of fluoropyram, you have strong properties for controlling germination and spore attachment and germ tube elongation, along with sporulation and reproduction at the other end. So how that looks with white rots, it being a little bit of a different disease, is certainly something that others like Mike could probably attest to. But certainly, I just wanted to illustrate the point that the two compounds should be very complementary when it comes to white rot control. This is just a graphic that I wanted to put up and illustrate to the audience today, where we have intentions of recommending Lunar. Just again at this stage to highlight, the product is not registered and we're not promoting the use pattern at all, but at this stage we're expecting a registration later this year, which I'll touch on shortly. But this diagram, I just wanted to sort of highlight where we're looking to have use of the product. So namely, the first application would be at flag leaf or early emergence stage, followed by potentially a second application if deemed appropriate, potentially 3 to 4 weeks later. So that's sort of where we sit right now. And I think that's probably going to complement the use of Alotron quite well. But there's a lot of other scenarios we're playing around with right now to see what's going to give the best performance for managing the disease. So by no means do we have those questions answered just yet. As I said, the product's going to be registered later this year. We're expecting it sometime potentially in Q3, maybe Q4 this year. The limitation of the active of fluoropyram will be to 2 applications only per crop per year. It's a function of the residual nature of the compound. It will, as I said, offer growers a new mode of action in group 7 to control the disease. But as I said, we have some very sort of big outstanding questions to answer, which is going to involve a lot of ongoing trial work, some of which I'm sure Phil will sort of look at under his project, and also Bayer will be doing directly with growers once we have a registration. So I've just put up there a few questions that I think we do need to look at answering, and that is, can Lunar potentially replace the need for tebuconazole as a fertilizer treatment? Can it give comparable or better control? Can the product, as a broadcast application and with irrigation or rainfall, can it deliver an acceptable product performance versus, say, a fertilizer or a carrier treatment such as tebuconazole on the fertilizer? And will that method work in dry versus wet soil. So fluoropyram is a very, it's a compound that it binds to soil quite readily. And that is something we need to look at in terms of dry versus wet soils. Can we incorporate the product via irrigation or rainfall in a manner in which we can get the product in and around the emerging root system to protect against disease infection? Or is it best to be put on a fertilizer or a carrier to get it down like tebuconazole is, as we see in the industry? So these are some of the questions that Bayer and others will work towards answering in future. But the good news is that we are looking at a registration later this year, potentially in time for some late season use in Tasmania, for instance. But it really does depend on the APV made there. So we'll keep the industry updated as we know more information. So yeah, that's pretty much it for me, Doris. I guess we could probably open to questions from there if you like.
Yeah, that would be nice. We can either type, or if you don't like to write the question down, if you stop sharing, Damien, people could just raise their hand, either physically or using the little symbol on the reactions in your toolbar on the bottom, and you can unmute and ask a question. So while we're waiting for some, one of mine is actually about mycorrhiza. Has anybody looked at whether mycorrhiza, is positive against helping against white rot infection? Is that something, Phil, you would be looking at?
Yeah, I'm not aware of anything, Doris, but there could well be. But certainly, yeah, as I said, we will be looking not only at synthetic fungicides, but also some biologicals to potentially, control or suppress the disease in the soil. And some of those probably could potentially be mycorrhizae or organisms that colonise the onion roots and protect them for white rot. So yeah, it's definitely something potential.
Yeah, there might be just for people to know, this our part of this project is going to finish at the end of May, and before that we will publish an international research scan. So there will be disease information, but I haven't seen anything really groundbreaking on mycorrhiza yet, but we still keep looking. So the participants and others can hopefully look forward to having a look at what research is done overseas. So we try just at the moment to compile that.
Doris, it's Tim Graham speaking. I have seen a paper on mycorrhiza. I think it was done in the same time they were looking at trichoderma.
Okay.
And there was quite a bit of activity. I think the problem with mycorrhiza will be compatibility with fungicides, I suspect.
Yeah, and I'm also thinking of looking at establishing or having soil health, so the mycorrhiza doesn't have to be introduced, but it's there.
Yep.
So I think it's part of a package rather than just saying, we get a bottle and introduce some mycorrhiza. I don't think that's going to work well if other factors are not right. Anyway, Tim, if you have, sorry.
Oh, sorry. When you're finished, it's Michael Sippel. I just want to add a comment when you got a minute.
Yep, you can go now.
So I'm up in Queensland. I was involved with work that Bob Davis and Jerry McManus did on white rot maybe 24 years ago. Did a lot of work with trichoderma. Was bringing up some different strains of trichoderma out of Tasmania, even trying to cultivate some local strains. Although the immediate results weren't there, once the trichoderma physically colonised in the soil and the local strains actually physically took over, they actually worked quite well. The problem is, and I get all the presentations around 80% control, 90% control, but that's not, in this day and age with the cost of, like particularly in Queensland where we hand harvest, a lot of hand grading, 80%, 90%, unless you're getting, in this day and age, you're getting, high pack outs, high yields, and good returns. Onions are a very tough game to be in. Now, sorry, just to get I got sidetracked, but on the trichoderma side of things, they actually work quite well. But when you physically get trichoderma colonizing on the base plate, it still becomes a non-marketable product. It might colonize around the sclerotes on the base plate, and you know, it has stopped the white rot from really moving too much on the base plate, but you still, in this day and age with supermarkets, becomes a non-marketable product. I saw all the initial work that was done with DADS, and you know, still to this day, 25 years later, it still has left an impression on me and all the growers in the region here. It's still by far what we've seen the number one, you know, number one tool that would, you know, give some level of effectiveness from what we've seen. You know, given the ability, you can put it down 12 months prior, still plant a crop and grow crops, and then go in the next year once the sclerotes have germinated the previous season, and go in and grow your crop. So it's still, you know, a great tool. I'm glad it's still being looked at, whether that be a synthetic product or a, you know, from onion tops or from garlic or whatever, because it, from what we've seen, it certainly does work.
Yeah, and it makes a lot of sense.
Yeah.
So hopefully, yeah, there's a bit of work going on in the US as well. I think last year, the year before, we actually had a speaker from the US. So that's worth following up. Tim Groom, did you follow up on that work? Is there any update you know of?
Probably Phil and Unga best to talk to that. I know they've been in communication with the guys in the US, but they're working on a slow release version of garlic oil, I believe. But Phil's probably best to talk to that, Doris.
Okay, thanks, Tim.
Yeah, it's a good point, Doris, and I didn't want to take up more than my 15 minutes, so I couldn't cover everything. But we are in touch with that group in the US. Jeremiah Dunn, I think, leads that now. Is Fred Crow, who a lot of you will be familiar with, I think sort of retired or retiring. So, yeah, we're in touch with Jeremiah, and they just summarised actually their data, I think, last month, and they were going to send it out to us once they have. So, but yeah, as Tim said, they're looking at potentially a slow release version of some of the germination stimulants. So that could be quite interesting, because I think, yeah, it's a matter of trying to get the maximum germination of sclerote. So if you can slowly release the compounds in small quantities over a few months, I think it will give a better result than a big hit up front of something. So yeah, we are communicating with them, and hopefully be able to learn from them, and they'll be able to learn from us.
Well, that's very encouraging. Thanks for that, Phil.
Doris, I just want to add a couple more things. There's a young lady based up here doing her PhD by the name of Jess Harper. Not sure if anybody in this meeting is aware of Jess, but she's actually doing her PhD on white rot based up here at the University of Queensland. I actually only talking to her this morning. So she's working on a lot of different things in her PhD project. So she'd be worth getting in touch with.
Yep.
The other one that was mentioned earlier about increase in root mass being less affected by white rot. I mean, in my role here, I've done literally thousands of onion varietal trials, and we actually find the opposite. The more vigorous root systems, anything that actually gets pink root handles the pink root better, they tend to find the sclerotes in the soil more. I know we're looking for higher root varieties, obviously, to combat pink root, but we'll see definite plot effects. Some varieties will definitely get white rot worse than the next plot, and then the common denominator there is just root mass. You pull a variety out that's got strong root mass, and whether it's finding the sclerotes more in the soil, we don't know. There definitely is some varietal differences there, but yeah, we've always put it down to the extra root mass, particularly on red onions here in southern Queensland. They tend to find the sclerotes more in the soil. So that's another comment I would make.
And it makes sense that, you know, if you have more opportunity for the plants to find the sclerotes, to them to meet each other.
Yep.
That's an interesting comment, actually, and certainly, as you know, even down here in Tassie, I'm sure you'd see it more in Queensland, that once your soil temperatures heat up above about 20, it starts to actually suppress the white rot. So they need those cool, wet conditions, and certainly you'd think, yeah, with the higher root mass varieties or bigger root systems, they're probably going deeper too, and cooler soils, wetter soils, and potentially more prone to that white rot. than the surface roots. So yeah, it's an interesting comment. Thanks.
So you're dealing with a beast. I mean, back when Jerry and Bob were doing their work here, I mean, we had, you know, like people had dams on their properties, and there was actually soil dug out of a dam that had never been dry, physically had water in it, and they actually took soil samples out of those dams and found sclerotes. And you know, the farmer believed it hadn't been dry for 20 years, and yet those sclerotes still germinated. So you're dealing with a phenomenal beast. I mean, it really is. Both the Sclerotium minor and the major, but they're both sitting there dormant until they see an onion in the ground or an allium in the ground, and then they germinate under ideal conditions. But the problem we have in Queensland is we're planting in the warm. So on heavy clay soils, you know, applying Allatron. I mean, a lot of growers, as Damien said, you'll put, you know, your Allatron. Some will use Follicur as well on a fertilizer and actually drill it under the onion, you know, a good 2-3 inches under where the onion is where the seed is going in the ground. And I've seen the strips of those where growers with the aid of GPS will actually physically drill that in 3 inches under where the seed is going. And it actually gives pretty good control, because I've seen the beds beside them in the untreated plots, and what it does, it stops the areas of white rot going from, you know, quite vast big areas to, it confines it to a very small area. So with the ability to hand harvest here in Queensland, you can actually guide the pickers around those areas. But yeah, we basically use that as a tool. It's done through cement mixer, and you know, you put the fertilizer in, it's drilled in under the seed. And as long as you aren't putting the fertilizer too close to the seed, it actually works not too bad. But to apply early rates of fungicide in the warm conditions, that's seeding here in Queensland, I think that's probably a waste of time. But the applications of fungicide have to happen, obviously, you know, under wet conditions through August, September, that time of year in Queensland. And the problem is you've paid to grow the crop. You spend all the money to grow the crop, and then just at the end when the white rot hits, you can lose it overnight.
So just one question, Michael, do you also then have problems with Fusarium given the conditions?
Certainly we do in the very late planted crops, what we would plant in June. Yeah, definitely. Yes, it is definitely a problem. Fusarium basal rot is not an issue in the Lockyer Valley. It certainly is at St George. A lot of those samples that Michael received, we did sample them from St George. It's certainly a big issue out there, but it's not an issue here in the other parts of the growing region. But pink root is probably our main issue late in the season as well. But white rot's a killer, unfortunately.
Yep. So here, 20 years, I mean, I think when I was involved in the onion industry, it was about 20 years ago, and we tried to produce onion oil. Made everything very smelly, but we didn't get very far.
But John Duff's done some interesting work too. Damien alluded to in the chat there about using some fumigants. Well, some plant-based fumigants. I mean, John's done some really interesting work there with some of the mustards and things, and done some pot trials, and they actually worked exceptionally well. So, yeah.
So the mustards are probably something to try again. Any more questions or comments? Our audience has been patient, but not very active. It'd be lovely to get some feedback if anybody has any, or any questions that, you know, research should address. Also feel free. I think from the invitation you have my contact details. Just contact me if there's anything, any questions, tips, comments on what has been done. I would appreciate that, because it's the only way of using levy monies properly if we know what people want. So if there's nothing more in the chat.
Just, I don't mean to say it here, but I think this needed to be advertised better. I only found out via a share on a Facebook thing on a cutout. So I don't see a lot of growers on this forum. I think it could be advertised a lot better. Use your industry partners in all the states to advertise it a lot better. I mean, I just found out via someone who just had a cut out of a page linked on, shared on Facebook. So
it was sent to all industry bodies.
But even to find the link, Doris, was
Just
really hard to find the link. You go to the Onion by Hort Innovation, try and find the link on there. It's not available. It was
Okay.
really hard to find the link even to register.
Okay, that's really a good feedback, because that's not how it should be. So certainly have to look at improving that. And I apologize. It was sent to Onions Australia quite a few times for distribution to all their members, because they got all the addresses. So yeah, direct mail to their newsletter list. So, but any ideas of how to do that better, it's really welcome. Because there's not much point to only get good feedback. I mean, we can only improve if we're told what we're not doing well. So thanks, Michael.
No worries.
And yeah, so please, you know, any criticism is actually useful to do things better. Oh, well, no, if you don't know, how can we do things better? Okay, we've used up our time, and thanks everybody for coming. Thanks a lot to the presenters giving their time to do this. And hopefully we keep going, or not somebody will keep going with the next phase of the communications project to keep industry informed of our research. So thank you very much.
Thanks, Doris.
Thanks, Doris. Thank you.